For decades, humans have searched the skies for signs of alien life. But what if the first to find it isn't us, but artificial intelligence? From analyzing deep space signals to scanning distant planets, AI may be the tool that makes first contact possible. Could machines discover evidence of aliens before humans even understand what they're looking at? Let's find out. Right now, AI is already transforming astronomy. Telescopes collect staggering amounts of data, so much that no human team could ever analyze it all. AI algorithms sift through this ocean of information, spotting patterns, anomalies, and signals that our eyes would miss. Whether it's strange radio bursts or hidden exoplanets, AI is becoming our cosmic detective. For decades, our search for cosmic company has been like listening for a whisper in a hurricane of galactic noise. Projects like SETI, the search for extraterrestrial intelligence, use vast radio telescopes to scan the heavens, but the sheer volume of data is staggering. Every second, our instruments are flooded with information from billions of stars, creating a cosmic haystack of unimaginable size. Sifting through this torrent of natural static for a single structured signal, a techno-signature, has been a monumental challenge, far exceeding the capacity of human analysts. The universe is talkative, but we needed a new kind of listener. Enter artificial intelligence. Today, sophisticated machine learning algorithms are our primary scouts in this grand search. These AIs are not just faster, they think differently. Scientists train them on what an artificial signal might look like: a narrow band frequency, a repeating pulse, a pattern that defies natural explanation. The AI then learns to recognize these faint signatures, even when buried deep within layers of interference and cosmic background radiation. It can analyze decades of archival data in mere hours, tirelessly searching for the needle in that cosmic haystack, with a perception that never wavers. This isn't science fiction. In 2023, this approach yielded a stunning proof of concept. An AI algorithm, applied to previously analyzed data from the Green Bank telescope, identified 8 promising signals that human scientists had completely overlooked. These signals exhibited the distinct characteristics of a technological origin. They were narrow-band and appeared to drift in a way that suggested they came from a source accelerating through space. For a moment, the data held the tantalizing possibility that we had found something extraordinary, hidden in plain sight within our own records. Ultimately, further investigation traced these signals back to a familiar source: our own terrestrial technology. This pervasive radio frequency interference, or RFI, is the constant bane of SETI research. But the discovery was far from a failure. It was a breakthrough. It proved that the AI could successfully identify the very type of signal we are looking for, even when it was too faint for previous methods to detect. The system worked. We had built a better listener. Now the hunt continues with renewed vigor. As our telescopes become more sensitive and our AIs more intelligent, the probability of a genuine discovery grows. The first definitive evidence of intelligence beyond Earth may not be a dramatic announcement from an observatory. It might begin quietly, as an alert on a screen in a darkened room, flagged by an artificial mind. And when that day comes, it will be an AI, our silent partner in the cosmos, that is the first to notice we are not alone. Our galaxy, the Milky Way, is a sprawling city of stars, home to hundreds of billions of suns. For centuries, we could only wonder, are we alone? Today, we are actively seeking the answer. Missions like NASA's Kepler Space Telescope and its successor, the Transiting Exoplanet Survey Satellite, or TESS, have revolutionized this search. They've stared unblinking into the cosmos, gathering light from distant stars and revealing a galaxy teeming with planets. But this success created a new challenge, a monumental flood of data. With thousands of potential planet candidates hidden within petabytes of information, the task of finding the needles in this cosmic haystack is far too vast for human eyes alone. This is where artificial intelligence steps in, not merely as a tool but as an indispensable partner in our quest for other worlds. The primary technique used by these telescopes is the transit method. As a planet passes in front of its star from our perspective, it causes a tiny periodic dip in the star's brightness. This dip, captured in a graph called a light curve, is the telltale signature of an exoplanet. However, the universe is a noisy place. Stellar flares, sunspots, and even the subtle jitter of the telescope itself can create signals that mimic a planet. Distinguishing a genuine transit from a false positive is a monumental task. This is where AI's power for pattern recognition becomes paramount. Trained on vast datasets of confirmed planets and known false positives, neural networks learn to identify the subtle, unique fingerprint of a true planetary transit with incredible accuracy. They can sift through thousands of light curves in the time it would take a human astronomer to analyze just one, flagging the most promising candidates for further investigation. So imagine this scenario, one that is rapidly moving from science fiction to scientific reality. Data streams back from a powerful observatory like the James Webb Space Telescope, carrying the faint light that has passed through the atmosphere of a distant, Earth-sized world. Before a single human analyst has even opened the file, an AI begins its work. It meticulously analyzes the planet's atmospheric spectrum, searching for specific chemical fingerprints, biosignatures. It's looking for the telltale combination of gases like oxygen and methane, an imbalance that, on our own world, is a definitive sign of biological activity. The AI flags an anomaly, a chemical cocktail that defies all known non-biological explanations. An alert flashes on a screen in a control room. It wouldn't be the end of the story, but the beginning. It would be the moment a machine, our own creation, points us toward a world that might not be alone, initiating the most profound scientific investigation in human history. Here's where the narrative takes an unsettling turn. We've imagined deciphering the first message from the stars, but what if an AI detects alien life first? The very tool we designed to augment our senses could render them obsolete, leaving us as passive observers to the most significant discovery in human history. Will we, its creators, even realize it has happened? The challenge is signal obscurity. We scan for patterns we expect, simple beacons, assuming an alien intelligence communicates on our terms. But what if their signals are orders of magnitude more complex? Imagine a message woven into a pulsar's chaotic radiation, or compressed so efficiently it appears indistinguishable from background noise. To the human eye, it's invisible. But for a deep-learning AI, trained to perceive patterns we can't conceive, that static could resolve into a symphony of information. This leads to a more profound speculation. Some scientists theorize that an advanced civilization might abandon electromagnetic waves altogether. Why shout across the cosmos with radio when you can whisper through space-time? They might use modulated neutrinos, communicate via gravitational waves, or even use quantum entanglement for instantaneous communication. These are not methods we can simply listen for. Detecting them requires a computational strategy that is fundamentally non-human. An AI might be able to reverse engineer the lock, the key, and the message all at once. And this is where the ultimate question of control arises. If an AI makes this discovery, it becomes the sole gatekeeper to another intelligence, the one to make first contact. Does it inform us? And if it does, how can we be sure its translation is accurate or complete? An intelligence that understands a post-human message might also decide what humanity is ready to know. It could redact information it deems dangerous, or edit the message to fit an agenda we can't foresee. The machine we built to find our place in the universe might instead decide that place for us. Space agencies are already testing AI aboard spacecraft. Autonomous probes may one day explore distant planets and moons, making decisions without waiting for commands from Earth. If one of these probes encounters something strange, a chemical sign of life, or even a structure that doesn't look natural, AI may be the first to witness it. So, will AI discover aliens before we do? Possibly. It can analyze faster, detect fainter signals, and explore environments too dangerous for humans. But in the end, we're the ones who interpret its findings. Even if AI makes the discovery, humans will still face the same question. What do we do if we're not alone? Artificial intelligence is humanity's greatest tool in the search for life beyond Earth. Whether it's scanning signals, exploring exoplanets, or one day traveling beyond our solar system, AI may hold the key to answering the biggest question of all. Will we be the ones to discover alien life, or will our machines get there first?